Okay, good morning, College View Wolves. We are here with a wonderful morning meeting. We've got Ms. Handziuk and our 10th grade student, Nicolle Torres here. We're going to talk about vaccines. And before we do that, I have a couple quick announcements. Athletic update. Congratulations to our boys soccer players who are playing for KIP this year and really crushing it, winning the Frontier League. So that's Benji, Miguel, Luis, Hector, and Axel. Congratulations. Girls soccer and boys volleyball starts on Monday in just a few days. So please make sure you are registered, bring your physical to practice. Practice is at 4:30. If you have any questions about this, please reach out to Coach Slaughter. And we also have Weightlifting Club with Mr. G on Tuesdays and Thursdays right after school. There is an interest survey. We will drop that link in the chat for you to fill that out if you are interested in some hashtag gains with Mr. G. All right, let's dive into vaccines. So Nicolle, you and I talked a little bit earlier this week and you shared that you had some concerns and some questions about the vaccine. So I thought who better to address those than our resident science expert, Ms. Handziuk. So Nicolle, I'll open it up for you. What are some of your questions and concerns?
My first question is, what does the vaccine do once it enters the body?
Yes, so that's a great question and something you'll definitely learn about in biology next year. Can you go to the next slide, Ms. Bell? So all the cells in your body contain DNA and RNA, which is like a code for making proteins which make up your whole body. I want to explain first what the virus itself does. So when you get a virus, any kind of virus, including COVID, it actually takes over your cell's normal machinery that it normally uses to make those proteins, and it injects its DNA or RNA into your cells. And then it uses your cell to make more of the virus and spread it throughout your body, which is kind of freaky to think about. So the vaccine is somewhat similar in that it's injecting into your arm a small amount of RNA, which is a little message that tells your cells how to make something. And in this case, what it makes is just the spike from the outside of a COVID virus. So one of those little tiny spikes that stick out on the outside. And by doing this, your body then is getting trained to recognize the COVID virus without having the full virus in your body. So your body makes this little protein and it starts to create an immune response so that your body is ready to fight off. If it ever sees that spike again, it's gonna fight it off in your body. So this is like what is in the vaccine. It is the small piece of that message that makes the spike protein, and it has lipid nanoparticles around the outside, which is kind of cool sounding, but it's just to keep it stable. Because actually your body is really good at recognizing mRNA and it breaks it down. So we actually, it will get broken down very quickly in your body, which is partially why it has to stay so cold and have this lipid nanoparticle around it.
How was it developed so quickly?
Yeah, so it was developed really quickly in part because scientists have been studying similar viruses for a long time, like SARS and MERS, you may have heard of, are like other respiratory viruses that work in a similar way to this COVID virus. So they already knew about the lipid nanoparticle, like the outside piece, and they just needed the genome of what the code was in this particular virus. And actually, scientists were able to sequence that genome back in December of 2019. So we knew exactly how to make the vaccine for this, and right at the start of 2020. And it just took all of 2020 basically to test it in humans, which got pushed through faster than normal in some ways. Like we got more, the government got approved to test it in humans faster because global pandemic, but all the evidence showed from doing that, all the people who were willing to get that vaccine showed that it was super effective and safe.
What's the environment inside the clinic like?
Yeah, so that's a great question. It depends on where you go to get your vaccine, but here at College View, I think it's really fun. These are some pictures from the vaccine clinic that we did this past Sunday, April 19th. we were able to give out 228 doses of the COVID-19 vaccine. And we had music going. We had Miss Fellows there welcoming people. Miss Handziuk was there as a volunteer. Miss Bodie. We had lots of staff there. And it was just a great opportunity to visit with people, learn about their families, and get them a vaccine at the same time. So it was fun. It was joyful and not a very scary place. And in fact, we hope that we are like supporting you guys by offering it in a space that is comfortable to you and that you know. And we're going to have another clinic here at College View. The first dose will be on Saturday, May 8th. The second dose will be on Saturday, May 29th. And the super exciting news is we were able to get the Pfizer vaccine this time. And that is the one that is medically approved to anyone 16 and older. So if you are a 16-year-old student or a 17-year-old student here at College View, this clinic is for you. We're going to send out registration information very soon. Please save these dates, and we would love for you to come and get the vaccine in a place that is familiar for you. What other questions do you have, Nicolle?
The age group, why is it specifically 16 and up?
Yeah, so normally when we come up with a new vaccine like this, they're going to test it in adults first. And for the Pfizer vaccine, they tested it in people 16 years and older. So it's very likely that it won't be long before we have one for younger people that's like approved for kids and stuff. But as of right now, who we have tested it in is like, for the Pfizer vaccine anyway, it's 16 and older.
Yep. Awesome. Well, thank you so much both for your time, and students, mark your calendar. We're very excited to offer this, and have a wonderful Friday. Thank you.